So good afternoon, everybody. And before we start, I would like to thank you all for your endurance and resilience, since we're going to talk about liquid or immersion cooling, and also the bar is opened to get some real liquid in. So you choose to be here, so thank you for that. So welcome also on behalf of my two guests on the stage, Edgar and Arno. They will introduce themselves when we commence with our, let's say, topic, immersed cooling. Before we start with that, to get the mindset clear, we are not to discuss only immersed cooling. We took it a little bit broader, discussing liquid cooling or the upcoming, we see a trend into liquid cooling into the data center industry. So that's basically how we are hopefully having a discussion which you will enjoy or you have questions on. But we see slowly the taboo of immersed cooling waning a bit. And with the introduction of the first projects, as Unica Datacenters, myself as a design, build, maintain contractor in Benelux and Germany, we are happy to work on a couple of projects where immersed cooling is introduced. And we see it step by step also into the industry that my, I would say, colleagues on the stage are working. We see that the taboo is waning and the introduction of immersed or liquid cooling is taking its place into the data center industry. Also, there's been discussions on sustainability of data centers today. The ability to increase the power IT load per square meter white space and also giving a higher return on residual heat and other facilities, other features that immersed or liquid cooling bring into the next step of sustainability in the data center industry. But before we continue on that, maybe, gentlemen, can you shortly introduce yourselves?
Yeah, my name is Edgar van Essen. I'm since almost 4 years the MD of Switch Datacenters. Switch Datacenters is an Amsterdam-based data center company, privately owned. Started as a hoster once, a long time ago, built their own data center, and then started actually build bigger and bigger and bigger. At this point in time, we're building an EMS4, which is a data center just close in Diemen, which will be initially 7 megawatts and will grow to 18 megawatts. And we're developing even bigger sites. So we're the Amsterdam specialist for data center development, mainly focusing on wholesale, but also more and more to hyperscale development. So for us, we made the full thing from retail co-location provider all the way to let's say, a real estate developer. And therefore, for us, residual heat is a very important topic.
Thank you. Arno?
Arno van Gennip, welcome. Equinix, since 6 years, I would say, having been responsible for operating in the Netherlands, 11 data centers. And recently switched over to a global role, being responsible for sustainability in the 245 data centers that we operate around the globe.
Thank you. When we were preparing this discussion, basically the first question I would like to direct to Edgar. Why are you interested in liquid or immersed cooling anyway?
Well, good question. I think I already in my intro briefly touched upon the topic. We are also a real estate developer, and for us, as finding the new plots in Amsterdam is also about giving value back to the community. It's not only getting the cheapest plot on the right location, getting the power and build some, well, it's a standard building. I think that was old school. That was data center 1.0. In Amsterdam, actually, the political environment and also the public opinion is much more of what do you contribute to society. And we think it's our duty as a local player, but also business-wise, it's a smart thing to already take residual heat delivery as one of the key design principles when we start building new plots. So actually for us, it's a critical element in getting the next new plots in Amsterdam, getting the proper power and the permissions. Without addressing residual heat, I think it will be tougher and tougher.
Thank you. Arno?
Yeah, for us it is, what does a new data center look like? What do we do with the existing data centers? How do you adjust them to allow for liquid cooling? Because there is no doubt that is the future. There will be chip manufacturers that produce chips that cannot be cooled with air anymore. And if you then stack it in a rack, you get to, in my opinion, at the moment, still absurd numbers such as 30 kilowatts a rack, 60 kilowatts a rack, and then with air, you are without a chance. So the question then is, how do you design your data center in such a way that you allow for that type of customers, where we don't think that there will be a 100% adoption of that type of cooling of all customers. So you have to build something hybrid. Yeah. And the question is then, how do you do that? Because ultimately, you will bring water to the racks.
Yeah.
So far, that has been forbidden.
I think that's an interesting point. When we, I think there's more or less three variants. First, you have your new to build data center, greenfield data center, which you can basically design according to, let's say, the new liquid or immersion cooled rules. I can come to that later a little bit from a contractor's point of view, but then I become a real techie, so I'm not sure if you would like to discuss technical issues. But on the other side, you have your existing data centers where you can either slowly work with a hybrid module, I would say in a period of 5 years from 100% air-cooled to maybe Arno or Edgar, 100% liquid-cooled. How do you do that? Do you have any opinion on that? Have you a vision on that? Or what is actually the problem that you are solving with liquid cooling, Edgar? Can you comment on that?
Well, the problem is just like Arno already said, some customers actually require liquid cooling in order to cool. So if you have a hyper HPC type of applications or AI, you already need to do it. So those customers you want to serve as well. So that's a real life problem of existing data centers. But in our case, we have data centers that are a little bit older sometimes, and we have a white space area that is very well fit for air cooling. But we also have a lot of other plots in the building that we actually can turn into alternative cooling areas. So there we don't have to build air cooling. We actually can quite easily build new areas in the same data center by adding piping systems and being ready for either immersion cooling or DLC. And immersion is even the form factor of immersion is sometimes easy if you just have a concrete slab and you have the power. You can quite easily put an immersion system in place, but not all end customers like immersion. So again, it's what type of customer do you deal with? What are their requirements? But I think the flexibility, that's what indeed is in the end needed in order to address all customers.
So I hear you talking about customers, but Arno, maybe can you comment on, do you already get that demand from customers, and how are you dealing with such demands? What's your vision on that?
It's slowly growing. Huh? It's slowly growing. So I would say that at the moment, at most 5% of our customers are asking, do you have this type of solutions, or we would love to install this type of density in your data center? And the answer at the moment, with a couple of exceptions, is, well, we cannot. But you still want to serve those customers, and you see the amount growing. So as Edgar said, you can adjust your existing data centers. Most of the data centers are designed to a different capacity than they're actually using. So there is that spare capacity, there is stranded power, things like that. And for me, the beauty with liquid cooling is that you could use your current system, and the output of your current system is water of, let's say, 27 to 30 degrees Celsius. That is perfectly able to be distributed again for liquid cooling to racks. How do you make that flexible? How many racks do you allow for? It is not only the liquid cooling, it's the power supply as well. Do you allow for 60 kilowatts a rack? Do you allow for 80 kilowatts a rack? The immense amount of cabling and UPS power, batteries, everything related to that comes with the question of liquid cooling. I think that for the coming years, we deal with, let's try to fit it in existing data centers. I cannot imagine at this moment that we will design a data center fully only for liquid cooling. If you then talk stranded power and sold for, well, let's say 30 kilowatts, and the customer is actually only using 15 kilowatts, that's lost.
So you get the demand from your customers. You see it slowly picking up.
Yep.
But you honestly speaking, you have to find a way how to accommodate that into your data center. So, Edgar,
yeah, well, we take a slightly different approach. We're the challenger in the market, so it's not strange that we actually stimulate our customers to think about liquid cooling. We actually have a business model in place where we also give some credits back to customers if they switch to liquid cooling. So in our EMS2, we actually proposed a quite interesting business model where I said, guys, if you want to go to liquid cooling, we're able to tap off your heat at high temperatures, and we can resell it on the market. We will be able to share a piece of that as a discount on your power bill. So actually, we try to change the business model and giving also reasons for end customers to change to different technology. So there are two ways of looking into this, this technology change. As Arno says, it will come. We think we have to be actively trying to push customers to think differently and to start thinking about new servers and generating higher, let's say, residual heat temperatures in order for us as a sustainable data center company to resell the heat and build a proposition around that. So it's a very active approach. I can fully understand Arno and Equinix that they have a different approach to that. We are not shareholder driven. We actually are entrepreneurs, and we can do things that we like to do. It's more different if you're in a big company. So we have a different active opinion, and for me, and the end result is that the residual heat is at least at 50 degrees Celsius end temperature. And whether it's immersion or DLC, in the end, that's less of an importance for us. So we try to create data centers where we are able to trade, in the end, the residual heat at 50 degrees plus. And that is an element for us in gaining the permits at the right locations.
Yeah. Thank you. Just to get back, I'm not sure whether you attended previous meetings as well, but the discussion was about the power use effectiveness, the PUE, and one of the people on the stage mentioned the CUE, carbon use effectiveness. What we see as a challenge coming through us from you as our clients or as our employers is to slowly start making a plan from 100% air-cooled via a hybrid version to maybe get back to that 100% liquid-cooled. Maybe similar to what we've seen in the car industry, from a 100% petrol-driven to hybrid to fully electrical EV, electrical vehicles. Are you actually making plans to change your existing facilities like a route or a way forward? Is that on your agenda? Is that talk in the board meetings? Edgar?
Yeah, well, actually, we discuss this actively with our customers, and we also actively discuss it with hyperscalers. Reason why we do it and the big ones don't is actually, we think there is a business proposition here to make, and also for the hyperscalers, there's a lot to gain because they all want to be 2030 carbon neutral. They all claim to be whatever green, but in the end, you also need to do things. And if you keep on building air-cooled data centers for the rest of the years, in the end, nothing will change. So we help them in gaining that momentum to 2030. So for us, we don't expect hyperscalers to make the big step immediately. So it will be indeed a phased approach. They will be most likely doing now 5 to 10% of their installed base, maybe with experimental technology in their perspective, either DLC or immersion. And the rest will still be air-cooled. But as long as there is a plan, and there is also commitment to move to bigger, then actually we can work together and jointly develop the right site at the right location.
And Arno, can you comment on that? How do you look at your existing fleet of data centers towards the...
Yeah, so different approach. And completely different approach, I would say, but ending up with the same thing. So adjusting your data centers to allow for liquid cooling, getting that higher return temperature of your water, using that to hopefully get a second life in with a different function. But for us, we are data centers. We do data centers, and we are not in selling heat to the community. That's not our business. We don't want to be involved. So you can get it for free, collect it wherever you want.
I quote you on that, Arno, that you will not be selling heat.
I will not be selling heat, and we will not be selling heat. No.
Okay.
No,
yeah, I
not
think
a product. We are in data centers.
I must admit, I follow Edgar a little bit. I think that ultimately the residual heat maybe will not be on the top of the balance sheet, but it can be an interesting thing. On the other side, I learned today, I wasn't aware that the situation in Ireland is basically that there's no more power available. We see in the Netherlands also the struggle to get power connections to the new data centers. With the use of immersion cooling, I think there's going to be a choice. Either you will have completely empty white spaces with just a few heat spots with high load on that floors, or you see that you can slowly enhance the IT load in your data center by means of liquid cooling. But then you also have to have a ramp-up model, negotiate this down with the grid operators to have a step-by-step. Can you comment on that, Arno? Is that something you see that will be part of the solution?
We will be part of the solution, and we have to be part of the solution. And so that's not, that for me is not the question. The only future for data centers is to be part of the solution and to support grid and to make use of that circular economy where you could say IT is a heat pump with a COP of 1, thereby we are producing heat. With the side effect of IT, so that all works, yeah? And then we need to find consumers of that heat, and it's easier if the heat is increased to 40, 50 degrees Celsius. Still not ideal. Still there is energy to be provided, and you have to transport it. That is the biggest problem. That is the most expensive part. But we will come in the situation that we have to use every bit of energy that we are consuming, and to prepare for that is the only right thing to do at this moment.
Do you have any idea of a timeline? And will it be in the next 3 years, 5 years, 10 years? Do you have any idea on how this will evolve over the upcoming years?
If I'm extremely negative or positive the way that you would look at it, but if Russia turns the gas down to Europe, then there is no other way than reuse every bit of heat that we have. That would accelerate things. If that doesn't happen, then in a period of 5 to 10 years, this will happen.
And Edgar, is it like an evolution or is it a revolution? What's your look on? How do you look at that?
Yeah, the technology is, in my perspective, evolutionary. Of course, there are revolutionary customers that want to have immersion from the beginning, a certain spot, but the majority will be evolutionary, I guess. So also technology-wise, we are in that sense very neutral, whether it's immersion or DLC. But there's another element, like you already discussed. I think the timing, especially now, everybody wants to burn less gas in the Netherlands. We take a much more holistic perspective to data center development than just putting a data center in place. We actually want to cooperate with heat plants and local residual heat networks. So what we prefer to do is actually build on spots where we already have heat networks in place, where currently gas turbines are producing heat that is currently being transported for public heating. And we just want to shut down those gas plants, replace it by a data center that are fueled by PPAs, wind energy, and actually you turn it from a system that is currently parallel organized, where you have gas turbines heating up residual networks and you have data centers doing their stuff. We want to have an integrated approach. So in the end, you can, if you do an integrated approach, you can shut off this gas burning plant. And you actually can reuse the PPAs of the hyperscalers to have green energy in, have it processed through a data center that generates heat, and then in the end you pump green heat into the public networks, saving CO2 as a total. But that takes a holistic perspective. You can't do that when you only look at the data center.
Thank you. We'll get back to you, audience, with some questions from your side. But since I see some well-respected data center designers in the audience, and also my own data center designers are here, we found that with the slow shift towards liquid or immersion cooled, some topics, technical topics come to mind, like floor bearing capacity. Do you still want to use a raised access floor? Yes or no? How are you going to deal with the enhancement of grid capacity, or are you accepting, let's say, great empty white spaces with some heat spots, call it that way, but nevertheless, on-spot cooling is always, as you just mentioned, Arno, a much more efficient way than cooling a full room with cold air, basically. But also topics when it comes to fire mist systems, actively being, for example, when there's a spill of liquid, cooling liquid, the effect of fire suppression systems on that liquid. Those are topics I wouldn't have dealt with a year ago, but they're now very active on our table. So I think, as you say, it will slowly be an evolution, but all those topics...
I can react to that. I think for every change, there's always fear. And there are 100 arguments why you should not be doing it. For me, this is a change we need to make in the data center industry, from going from diesel driving to electric. That's the perspective that I have. We believe in electric driving. We believe it is the same mobility with even less noise and less components and more sustainable. So we don't. We can list hundreds of reasons why the diesel engine is even better or nicer and sounds better. But in the end, we need to make this change. So in my perspective, we all, and that's why we are Challenger, we believe it will be the future, and we start, let's say, promoting the future already now. There will be hiccups for sure on the road, and we might run into things we don't see yet. But we believe this future needs to be done. Instead of that, we keep on developing the next phase of the diesel engine. And start manipulating the software to make it look better. You know?
Thank you. Arno, you want?
A couple of your direct questions. So raised floor, no, there's no future for a raised floor with liquid cooling. It's way too heavy to do that. Plus all the sustainability questions on that. If you've got the concrete floor and you can put a rack on it, why would you then do steel and wood and plastic to do on top of that? That makes sense when you are transporting air, where you've got a huge air duct. Once you don't do any air anymore, or it is less important with liquid cooling, then the raised floor is gone. Other questions that you had. How does it look like? And I think that is a question that cannot be answered at this moment, because I cannot imagine that we design a data center with an average rack density of 30 kilowatts or whatever that future will be, because your risk of stranded power is way too high. But then designing a room with a couple of racks in it is a waste of space.
Yeah, doesn't make sense either.
And that's the big question on how. And in the upcoming time, that's pretty easy, because you can adjust your existing data center to allow for liquid cooling on a couple of spots. But for the new data center, if you start from scratch, that's a good question to have.
Yeah. Edgar, if you don't mind, I'd like to get to the audience, because before, actually I'm the only guy having some liquid in this room. So I can already feel the cold from the beer coming upstairs. But before we get to that, any questions from the audience? Anybody? Yes? Sir.
My question is, there are different ways.
Just hold on a second. By experience, I know that's quite hard to understand if you are in the back of the room hearing the question. So.
Okay, my name is Martin Matze. I have a question about liquid cooling. There are different ways of liquid cooling, and one of them is immersion is only one of them. Do you see a future of immersion, or do you see the future in other ways of liquid cooling?
Edgar, can you comment on that?
Yeah, I think we already said we're neutral for us. My personal opinion is that immersion is the end game, maybe, but it might be a little bit early. It's a more revolutionary concept. At this point in time, there are also a lot of arguments why you should not want to have it. I think in real life, there are HPC servers being made by the regular manufacturers, the Dells, the Supermicros. They are already DLC enabled that fit in a 19-inch rack. So that is a current ecosystem that fits in the current way of planning data centers. If you add a rear door cooler to that, and you have let's say a liquid management system that already works, I think the evolutionary perspective is the most likely one, but there are also some good innovations, like Axora in the room here. They try to actually build immerse systems into 19-inch racks, and then actually start combining a little bit the goodies. So my personal opinion is I'm a more believer in evolutionary steps, DLC, rear door cooling, and for certain specific applications, immersion might be the right way. But if a customer comes to me that only wants immersions, I don't care. For me, they can sign tomorrow.
Arno, do you want to comment on that?
Yeah, but briefly, I would say that the future of this fully depends on manufacturers and suppliers. How well their product will be able to use, the operating ease of these products, and their connection to IT manufacturers. Yeah? And the one that has that best connection, the easiest product, that will win the game. And what that is,
we will see. Any other questions? Yes. One more minute. Yeah. Eén vraag. One question. So.
Good afternoon. My name is Willem Ibema from Submer. I'm representing immersion cooling supplier. The discussion, my question is, or my comment is more that we have discussed about the amount of power per rack. But what we see is that the discussion is more about the application. And when you talk about the application, about the AI, machine learning, and those kind of applications, then you see the need for very high density compute. And it's the application that's now driving the whole need for, well, let's say high density, and then of course then there are different options: DLC, immersion, single phase, dual phase, all those kind of things. And yeah, personally, the jury's still out on what's going to be the way forward. And you see a lot of good initiatives out there, and the proof of the pudding is in the eating. And that's where it all comes down to. You have to just.
We have to make some pudding.
You have to make. We have to make the pudding.
I think there's room for one more question. I saw somebody. Yes, if you don't mind. Oh.
Yeah.
I see the audience is still awake, so.
I've heard multiple calls for regulation on this topic, especially in relation to the discussion about the hyperscales, that to actually, prohibit air cooling and make sure everything is liquid cooled so that you can actually use the residual heat better. What is your stance on like regulation on immersive cooling?
it's not yet there, and I think it needs to be developed. But if you would say that IT cannot be air-cooled anymore, then that will not happen in the first 20 years. So It's a matter that there are applications out there, and I agree with this gentleman, applications out there that need immersed or liquid cooling at this moment. And that will grow, and probably grow faster than we can imagine. But there will always be applications that do not need that density, and therefore will be air-cooled.
I see Edgar wants to comment on that.
I tend to disagree. I think technically you're 100% right, but there are more axes than the technical axes. You also have political pressure, you have societal change, you have the drive for sustainability. I think at this point in time we have reached a certain momentum, as we saw in the Netherlands, whereby Meta trying to build a data center somewhere in the middle of nowhere without a heat recovery plan. People actually don't want that anymore in the Netherlands. So you can be technically right, well, but I think in the end, the government and the regulators, they will define the pace, whether this is picking up rapidly or not. If the regulators actually stay calm and they don't do anything, then Arno is right, then it will take ages. Just like if you don't stimulate electric driving, everybody will keep filling his diesel and nothing will change. So I think it will be the regulator in the end who will be defining the pace of acceptance of new cooling technologies. You could even go, for instance, in a very simple model, and start taxing the fan on a server, because that's the root cause of everything. If the server is cooled by the fan, you build an air-cooled data center. If you build an air-cooled data center, you will never go to immersion or to other. So it's just a way of thinking. So by just switching one little thing in the model, in the business model, by a regulator, you can actually turn the whole system in a much faster change. And I think that's what a lot of people don't understand, that we're at the beginning of a structural change. It's no longer that engineering defines the future, it's the political pressure that defines the future. That's my perspective.
I think just to comment also a little bit on that, during this afternoon there was also a discussion on metrics, PUE, CUE, and I think it would be a good step towards regulation to allow, let's say, immersion or liquid cooling to be part of, let's say, the PUE calculations, to actually show that immersion or liquid cooling enhances or decreases, whether you look at the number, but decreases the number or enhances the power effectiveness. And secondly, but this is maybe for our Dutch operating model, we see that the residual heat, when you produce a 100% green power residual heat from a data center, is not recognized as renewable energy, the heat actually. So it needs to be adopted in the calculations towards what we call sustainable buildings. When you actually connect a house to residual heat that is produced by a data center, you will get not a bonus. You are not basically seen as a green initiative. So I think towards regulation, that would be, in my opinion, a first step to take these items in. We're running out of time, but there's nobody behind us. So if there's another question, feel free to leave. But if there's another question...
I would like to try the liquid cooling myself.
Yeah, we need some liquid cooling. It's quite hot in this. But if there's another question, just shout out. Otherwise, I would thank you once again for your resilience. And I hope that in the steps that are ahead of us towards liquid or immersion cooling, we can meet each other. And we are always open to discuss those topics. And I wish you a very cold liquid downstairs. Thanks for attending.